that you turn in your sham auction permission form to me if you're working at the auction. And don't forget Mash League t-shirt order forms are due Thursday. I need your permission slips tomorrow if possible.
You still need one if you're 18.
Yes. I just like to be able to get a hold of a parent if I need to. Which I probably won't, but just in case. Okay, so I'm just going to make up some problems that kind of correlate with this stuff that we learned on, or that we talked about on Friday. So let's just take a couple of vectors, totally made up vectors here. And let's have you find, let's pretend this is question 1, okay, and this is question 2. So these are the skills we need to make sure we know how to do. These are the main skills we learned or talked about on Friday. So, how about this first one? Yeah, we're finding the dot product. So A dot B will be, you said you what, Madeline?
Multiply the x's.
So we're going to have -2 times 1, which is -2, and 12. And what are we going to do with those two numbers? Add them. So the dot product is 10. Everybody got it? Okay, now we're going to find the angle between these two vectors. Now that uses this, remember? What do we know about the dot product? What does that 10 equal?
The diagonal line.
The magnitude of the first vector,
Yeah.
which is what? What's the magnitude of this vector? How do you find magnitude? Square. Square, add them together and take the square root. So the magnitude of this vector would be 2 root 5 or root 20. For this purpose, it might be easier just to leave it root 20, but it's completely up to you. So that's the magnitude of A. Now I need the magnitude of B. What's the magnitude of B? Root 10 times what? Dot product equals magnitude times cosine of the angle between them. Right? So then what do? I'll bring it up here. So we have 10 equal to root 200 cosine theta. So cosine theta equals 10 over root 200. Now what do?
Calculator.
Calculator.
Cosine.
Second cosine.
Yeah.
And the answer should be oh my, I got 45. I guess that makes sense. Did you get 45 degrees? Okay, quiz tomorrow. Probably going to have to do this problem, probably going to have to do this problem. Any question about that? Okay. Now, take the same two vectors. We're going to determine if they're parallel, perpendicular, or neither. By the way, vocabulary. What's the vector word for perpendicular? Orthogonal. Very good. Orthogonal. What's the vector word for length? Magnitude. What's the vector length or vector word for sum? Resultant. And what do we call real numbers in vector land? scalars. Good vocabulary. What's the definition of a vector? Directed line segment. Good job. Okay. Now, these are two-dimensional vectors. So if you want to know if they're parallel, perpendicular, or neither, you can just simply check their slopes. This vector goes left 2 and up 4. So what's his slope? This one has a slope of 4 over -2, right? Remember, what slope? Y over x, right? What's the slope of this one? 3. Tell me about these two vectors. Parallel? No. The slopes aren't the same. Orthogonal? No. The slopes are not opposite reciprocals. Therefore, these are two random vectors that have a actually 45-degree angle between them. Right? Okay. One thing I do want you to keep in mind, we talked about this on Friday, you do not have to use it, but what do we know about orthogonal vectors? What is special about orthogonal vectors and their dot product? If vectors are orthogonal, their dot product is 0. 0. So you do need to keep track of that. You do not have to use it right now, but you will later. If vectors are orthogonal, their dot product will be 0. Okay? All right, and finally, 3 random points. Now this tests a lot of skills, this problem. 3 random points. They would make a triangle, assuming that they're not collinear. They're going to make a triangle. And your job is to find the measure of angle B. Now, we already did that. That was question number 2. We found the angle formed by 2 vectors, right? That's exactly what you're going to do here. The difference is you don't even know what the vectors are, so you have to start with that. If this is the angle we are looking for, then we will begin by doing what? Finding the vectors that make the angle. And what are the 2 vectors that make the angle? BA and BC. So we must start by finding the coordinates of vector BA and the coordinates of vector BC. Groupies, if you're looking for angle B, you must use those 2 vectors, the vectors that emanate out from B. Got it? If you use other vectors, you will not get the right answer. Okay, so what are the coordinates of vector BA? That's starting at B, stopping at A. What are those coordinates? 7 to -1, -8, 5 to 3, -2. Yes, Jerry?
Did it warm up?
Yeah, it's warm in here. Thank you. Okay, from B to C. From B to C. -1 and -3. Is everybody okay with those coordinates? So now think of the second question we did a minute ago. We had 2 vectors, I called them A and B before. We had 2 vectors and we found the angle between them. That's exactly what you want to do here. Okay? So what do we do? What are the steps to finding the angle between those 2 vectors?
Dot product.
First we'll find the dot product. And the dot product will be, dotting these 2 together, we get 8 plus 6. You get 14?
Yeah.
And what do we know about that dot product? What does it always equal? The dot product will equal magnitude of the first vector. Okay, what's the magnitude of this vector? The square root of 68. To find magnitude, the square, add them up, take the square root. It's the Pythagorean theorem. This vector goes left 8 and down 2. So its length would be 64 plus 4, right? The square root of 68. What's the length of this vector? Root 10 times the cosine of the angle between them, which would be B. So 14 equals the square root of 680 times the cosine of B. So the cosine of B equals 14 over root 680. Did you get like 57.53? So that answers this question right here. Find the measure of angle B. Right there it is. Okay, let's go through those steps again. Gave you 3 random points. So what was the first thing you did? Find the coordinates of the 2 vectors that form the angle in question. Then you found the dot product and set that equal to magnitude times cosine. Got it? Okay, next. Now we want to find the area of this triangle. Now keep in mind that BA has a magnitude of root 68 and BC has a magnitude of root 10. You have already figured that out, that this is root 68 and this is root 10. So you know this length, this side of the triangle, and you know this side of the triangle, and you now know the angle in between. So we can find area using, what's our formula for area? One of our formulas for area? 1/2 side times side times sine. So your area will be 1/2 root 68 times root 10 times the sine of the angle that you just found, which is sitting on your calculator, so you don't need to round it off. You can just take 1/2 times the square root of 680 times the sine of your answer. Whoa, did you get just 11? Remember, I did not type this angle in, I used it straight from my answer button. That prevents all round off and allows me to get a nice, neat answer. Okay. Does anybody have a question about any of those?
I got like 700.
I don't know what to say.
It was just root, is it root 68 times root 10 times the sine divided by
1/2.
Yeah, she said divided by 2, so yeah. Did you close your parentheses after your radicals? Did you take the sine of the angle? It's impossible for you to get that big of a number.
Is it in writing the answer? And I did that as typed in. Oh, I did the sine.
Okay, now I want to show you something. I can't remember if I showed you this not on Friday. Did I show you a slick little way of finding the area? I don't think I showed you guys. Here's what I'd like you to do. This is not on the quiz, but if you want to remember it and use it, it's absolutely fine. Here is another way of finding the area of this triangle, and this is one of the coolest things you're ever going to see. This is amazing. We have already found the area of our triangle. We know it's 11, right? Go back to the 2 vectors that you made in the very beginning and set up a little determinant. Now, you talked about determinants last year. We have not talked about them yet, but just set up a little determinant with those 2 vectors. Just don't rearrange them or anything, just set up a determinant. Does anybody remember how to evaluate? This when you studied matrices last year. You studied what are called determinants with these vertical bars. Does anybody remember how to evaluate that determinant? Yes. Katie, you're kind of, yeah. You multiply these two together, so you get 24. Now again, this is not on the quiz. I just want to show you this because it is so amazing. This is 24. This is 2. And then you remember you subtract those numbers. When you find a determinant, that's what you do. So you take 24 minus 2. What's 24 minus 2?
22.
And what's half of 22? That's another way to find the area of the triangle. Is that not the coolest thing? So all you have to do is build two vectors, evaluate their determinant, cut it in half, and that will be the area every time. That just is like it's true. That's just so cool. Okay, all right, there's one more thing on that page we need to talk about, but now I want to go back to page 6.1 notes. 6.1 notes, because there's some stuff on here that will be on the quiz, and I want to make sure we review it too. So far, I have 4, well this one had 2 parts to it, but I had 4 quiz questions for tomorrow, right? Okay, let's add to that now. Let's look at 6.1 and see what might be on the quiz in terms of the 6.1. Now, can we already do problem number 1? We've already had to do that with our triangle problem, right? We had to make the vectors. So what would be the coordinates of the vector from A to B? 2, 2. So if that question's on the quiz, that's like a gimme, right? Those are easy points. That's 2, 2. Okay, what do you do with a number out in front? Like in problem number 2, there's a 2 out there. What do you do with that 2? Yeah, so BC, just BC, would have what coordinates from B to C? -4, 2. And then if we double that, that would be -8, 4. Does everybody get that okay? And what do we call this 2? A scalar. That's called a scalar. Okay, how do we add vectors coordinate-wise? Let's see, BA would be -2, -2. And CB would be 4, -2. So what happens when we add these? How do we add these two things together? Anybody remember how to do that? Add the x's and add the y's. Do you remember the airplane and wind problem? That's exactly what we did with the airplane and the wind. We found their x's and y's and then added them together. Okay, let's look at part 4, number 4. Okay, so number 4 says I need AC to equal BD. So here's AC and here's BD. I need them to equal each other. That means they have the same length and they're pointing in the same direction. Point A is 1, 2, and point C is -1, 6. So tell me the coordinates of this vector. What are the coordinates of the vector from A to C?
-2, -4, +4.
-2, +4?
Yeah.
Now you need BD to have the same movement. You need BD to go back 2 and up 4. That's what this vector does. It goes back 2, left 2, and up 4. You need this one to do the same thing. But it has to start at 3, 4. So can you figure out what the coordinates of that point are? Now remember, you're starting here but this is how you're moving. So you're going to go back 2 and up 4. So where would you be? 1/8. What does the notation in number 5 mean?
Magnitude.
Magnitude. And how do we find magnitude? Square, square, add them up, and square root. Right? Number 6 looks way more complicated than it is. What would you have to do in number 6?
Find the magnitude of both things and then add them up.
Actually, no. Actually, first we would add them up and then find the magnitude of the sum. Okay, Stephen, we gotta do what's inside first.
Okay.
So we're gonna do 3BC, just multiply by a square, so it'd be 3BC, not 2BC, but do 3BC and add AB. Then you're gonna have a vector, then find its magnitude. Okay?
All right.
Number 9. Anybody remember how to do this? U has coordinates 1, -1, okay? Anybody remember how to find a unit vector in the same direction? This will be another quiz question for sure. John Preston's doing the right thing. He says, I forget, Mrs. Ford, but I know it's in my notes. I'm looking back through my notes. Yeah, exactly what you do. If you want to turn this into a unit vector, you simply take his coordinates and divide by the magnitude. What's the magnitude of that vector? Square root of 2, square 1, add them together and take the square root. So it's root 2. And I even told you, if you were listening, I'm not even going to force you to rationalize that. You can just leave it like that if you want, or you can rationalize it if you want. That's a unit vector in the same direction as U. Okay? What would be a unit vector in the same direction as V? This isn't on the paper. What would be a unit vector in the same direction as V? What's the magnitude? Root 29, so we're going to divide them both by root 29. There you go. Number 10 is another quiz question for sure. You've got a vector whose magnitude is 6 and whose direction angle is 40. Your job is to find the components or the coordinates of that vector. So in other words, you need to find x and y for this vector. Do you remember how to do that? Yeah, we had to do this with the airplane problem. If you think about the triangle here, isn't this x and this y? So sine 40 equals y over 6. So you would do 6 sine 40. And then how would you find x? Same thing, only you'll use cosine. So cosine 40 equals x over 6. Now, does anybody remember the extra little thing you have to be on the lookout for with these problems? Yeah, you have to be careful. Sometimes they're negative. Now, in this case, given where we drew that picture in quadrant 1, x and y, whatever those decimals are, will both be positive numbers, right? But that only happens if you're in quadrant 1. If you're in any other quadrant, something will have to be negative, and you'll have to pay attention to that. You all right with that? Number 11. Do not, this looks so complicated, this will be a test question, something with I's and J's will be on the quiz. Do not be confused by that. What vector are we talking about? 2 i's minus 4 j's. What is that? That's very simply, that's just the vector 2, negative 4. Remember, I is horizontal steps, j is vertical steps. So if you're taking 2 horizontal steps and negative 4 vertical steps, this is what you are. And what do those vertical bars mean here? Magnitude. So the magnitude would be the square root of 20 or 2 root 5. Everybody still with me? Now, we've talked about all these things before. We need to do number 12 because that'll be a quiz question for sure. It is the opposite of this one. This time I'm telling you x and y, and I want to know the magnitude and the direction. So let's draw it just like you drew that one, only we're going negative 3, 4. Everybody okay with that picture? That's your x and y. Now you need your magnitude. What's the magnitude? 5. Pythagorean theorem. Square, square, add them up, take the square root. Now I need my direction. This is actually going to be the answer. Does everybody understand that? That will be the direction angle. But you're going to find this one. I'll call that theta. So what will I type into my calculator to find theta? Second tangent, 4/3. I'm not even using the negative. You can if you want. I just want to know how big that angle is. So second tangent, 4/3. I got 53.13. Right? So what's the actual direction then? Point, what would that be, 87?
If we did 9 and we divided by 11.
Yeah, that's right here. Okay, let's see what's on the back side here. Okay, now, number 14. I'm going to take the vector negative 2, negative 3. Make that a unit vector for me. This is number 14. Make that a unit vector. What would the unit vector be? Oh my, we just talked about it. So I'll just divide everything by root 13. So this is a unit vector now, which means what is its length? 1. Problem number 14 says I want it to have a length of 3. So right now, this thing has a length of 1. If I want to make it 3 times as long, all I'm going to do is what?
Times it by 3.
Times it by 3. So this would be the answer. That has a length of 3. So if you want to change the length of your vector, first of all, make it a unit vector. And how do we make it a unit vector? Well, divide it by its magnitude. Once you have it a unit vector, then just multiply it by whatever length you want. So in this case, we wanted the length to be 3. It told me in the problem, it said 3. So I took my unit vector and times it by 3. If I wanted the length to be 7, I would take my unit vector and multiply it by 7. Down at the bottom, vocabulary. Vector, we already talked about it, let's do it again. What's a vector? Directed line segment. What's a resultant? Sum of 2 or more vectors. What's a scalar? A real number. What's a unit vector? Magnitude 1. Any vector whose magnitude is 1. And how do we make something a unit vector? Divide it by its magnitude. Position vector. I don't think I've used this word, but we've used the concept. Anybody want to guess what a position vector is? It's a vector in standard position. Do you have any idea what that means? It starts at the origin. It's any vector who begins at the origin. That's what a position vector is. So when I draw my vectors, like I've drawn one here, I've drawn one here, I start them at the origin. They're called position vectors. They're in standard position. Magnitude, length or distance. You okay?
Yeah.
All right. Null vector. Again, a new word we haven't used, but in parentheses I put 0 vector, so you probably know what that means. Any idea? What do you think his coordinates are? 0, 0. The null vector is the vector whose coordinates are 0, 0. Now, I know what you're thinking. You're thinking, isn't that just a point, Mrs. Ford? If I draw it, it's going to look like a point. But we need this concept because when we add 2 vectors, we get another vector. So if we added 1, -2, and -1, 2, if we added these together, we need to get another vector. And what would be the coordinates of the vector we got when we added these together? 0, 0. This is what happens when you add a vector to its opposite. You end up right back where you started. So basically, you've gone nowhere. No x's, no y's. That's called the null vector or the 0 vector. Any idea what we mean by initial point and terminal point? Where you start and where you end. So when we talk about vector AB, point A will be the initial point and point B will be the terminal point. If we have a position vector, what will be the initial point? 0, 0, the origin. The origin is the initial point of any position vector. Standard unit vectors. I and J. Why are they called standard? Because they are the horizontal and vertical. Velocity and speed I'm going to wait to talk about tomorrow when we do parametric equations. All right, we have one more thing to talk about. It will not be on the quiz tomorrow, but it is the last thing on the 6-2 notes. So is everybody clear on what you need to know for tomorrow? Okay, and just so you're kind of keeping up to speed here with what's happening, we will have our quest over all this will be a week from today. So tomorrow we have our quiz. We're going to learn about parametric equations tomorrow, and then we're going to review Wednesday and Thursday, and have a big quest on Monday. Okay? All right. So last thing we need to learn here. This is not on the quiz. It will be on the test. Last thing we need to look on page 521 at number 52. Page 521 at number 52. We are going to talk about the physical concept of work. Anybody in physics know how we calculate work?
Yeah, we didn't do this stuff a while ago.
I don't remember. No, Lord.
Has something to do with power.
It's a force times the distance times the cosine of the angle between them. All right, so we want to look at this problem. It's a little bit complicated, but I think you can handle it. Problem 52. We have work. We want to find the work. The force has a magnitude of 24 pounds. So the force has a magnitude of 24. It's moving an object 5 feet from 0, 0 to 5, 0. So the object is moving on the horizontal. Would everybody agree? And its distance is 5 feet. Now the force is acting at a direction 4, 5. So that means the force over 4 up 5. This is the direction of the force. It's like the slope of the force. Now, this is the distance, and this is the force. This is the angle in between them. The object is being moved horizontally. It's like me pushing this chair. This chair is going to go across the floor, right? It's going to go horizontally, but the force coming through my arm is acting at an angle. We need to know the angle in between the force and the distance. Yes, Jessica. Okay, the distance is 5. What I'm trying to depict here is not, and this is 24. But I'm not putting all those numbers into the picture right now. They don't jive in the same picture. I mean, I could make them so, but then these would be fractions, and I don't want to mess with that. Here's what I want you to think about. Just this part right now. I'm just thinking about this part. I have a force, or a distance, forget how big it is. This is the direction that the force is, or that the direction is in, the distance is in this direction. Would you agree with me? It's moving horizontally. The force is coming in at an angle. Again, forget how big it is. It's coming in at an angle. What angle is it coming in at? I need to know that angle. And what I do know about it is the slope of that force is over 4 up 5. That will allow me to find the measure of this angle. Then, once I have that angle, I can go back and make a new triangle if I want with this exactly 5. I can do that. But in terms of finding the angle, all I really need is the slope. Do you see what I mean? I am not drawing, all I'm drawing here is a picture of the force. The slope, they told me in the problem, it was over 4 up 5. They told me that in the problem. It said the force is acting at this direction. Now, how can I find this angle? I would do second tangent. And so that angle is 51.34 degrees. By definition, work is force times distance times cosine of angle between. What's the angle between? Yep, so I'm going to take 24 times 5 times the cosine of my answer. And the work is 74.96. And usually the unit on that is foot-pounds. Let me read. Yeah. Okay, that's not as hard as it might seem the first time we do one. Let's get one more set up real quick. Let's say we have a force of 18 pounds acting in a direction of 2, 3. And you're pushing an object horizontally 10 feet. All right, so how much work will be accomplished by a force of 18 pounds in this direction, pushing an object 10 feet horizontally? All right, so here we go. How much work? Work is going to be force times distance times cosine of angle between. So here we go. What's the magnitude of the force? 18. What's the distance that we're moving the object? 10. What is the angle between them? We have no idea, but we know that angle has a direction of 2, 3, which means it has an angle of what? Second tangent. I got 56.3. Second tangent 3/2. So that would be the cosine of 56.3. So I'll take 18 times 10 times the cosine of my answer, and I get 99.85 foot-pounds. That is not on the quiz tomorrow, but that will be a quest question next Monday. Okay? Now, for tomorrow, there's no additional homework. Finish the 6-1 and 6-2 assignments that were made on Thursday and Friday. Okay? John, can you hit me off? Thank you.